Swayam Prabha. Digital India. Educated India.
So here we go. Our notebook is ready. So next thing to do is I've explained all what you can see here. So let's just go quickly so that we don't waste time. We go to run the notebook. So the first thing we have to do is to set our environment variable. We set the environment variable to user underscore experiment diary. So it will be under workspace classification. This one is by default. Then the next one is what? Where we have our data. So we are setting this part. This is what we are setting this part to data. So this is to data. Then we set for our specification workspace to the specification file. This is for this specification file, the part. So why we set this is that we don't want, along the line, we will need those parts and we don't want to be writing lengthy part that way. So it will just be represented by all these variables here. So the next one is we need environment key. Now the environment key, you need to have an environment, your key for the tau key. So what you need to do, API key is called API key rather. You need to register on the NVIDIA NGC first. These are the steps you need to follow, but I will show you the step now. Let's quickly run that. So when you get here, when you pull your container, you don't need any registration, but now you will want to get our API key. So what we need to do is when you come here, okay, let me go back to NGC here. This is the first page. You see where you have guests here. So what you need to do is what you click on sign in or sign up. Sign in or sign up. So when you have your sign in or sign up, when you get here, you make use of the NVIDIA account, use existing account, continue. That's the one you click, first one. So because I have an account, I can continue this way. For those that have not registered at all, you can click on different account. You will see where you sign up. So after you sign up, you can come back and then log in. So once you log in, like the way it's going to allow me to log in here. So I'm logging in now. So yes, what I'm looking for login, then you will see this place will change. It will no longer be guest. You see it has changed to my name here, programmer. So what you need to do next is to drop it down and click on what? Setup. So you click on setup and it will load. So you need an API key. So you can click on the get API key. So when you click on get API key, the next phase to do is to generate. You click on generate. But because I have key, I don't need to click on generate again. So we can come back here and say, see, so when you click on the API key, get API key, it will bring this interface. So on this interface, you will click on generate. When it generates, here, you will see the API key here. So you copy it and save it somewhere. So anytime you want to work with using your NVIDIA Tau, you can now paste the API key and make use of it here. So this is our API key, which is being used. So the first thing to do now is to run this cell. So I'm going to run this cell. So everything is initialized this way, running this cell. So the next one is to let me see. I want to know if my data are visible. So I want to look at the test data to look at what just one class there, cat. So it can fetch, that is, oh, okay, it's reachable, our data is reachable. Then the next thing to do is to see what are the available pre-trained model for classification that exists here. So with this NGC registry model list, it will list them, NVIDIA / TLT pre-trained model underscore classification star. That is all. It should show all. It can show all to you. So we'll be able to see the list of all the, yes, it has shown all of that. So you can see versions, VGG19, VGG16, the accuracy, the epoch, you can see, so there are many of them there. ResNet 50, 30, 34, 18, 101, and all of them. So we can make use of, you can make use of any of them that are there. So you can make use of them. So the next phase, not to waste time, so is to what? Since we know the pre-trained model that exists, we can now make a folder, a directory where we'll save our downloaded pre-trained model. So let's create a directory called pre-trained ResNet 18 because that is what we want to use. So I'm running that. So that is done. You can see when it gives a number, it shows it has run. And then, so now let's pull that what pre-trained model into this directory here. So how do you pull that? You have you write ngc registry, the model, then download version. So we have NVIDIA/TLT train classification. So what kind of model? ResNet 18. The destination, you should save it here because we created this folder, this one, we created it here. So it's going to, you should save it in this destination. So I can run that now. So it's going to run and we can see how our model will be downloaded. So the download has begun. So while that is loading, so once that is completed, the next thing to do is to just verify and see whether it's the directory is the right directory. So just confirm if it is the right directory. It's because of the SSH, it should have been much more faster than this, I guess. Should be faster than this. So that haven't done okay, yeah. So it's done. So the model has been downloaded. So we can view the model here. So the model ResNet underscore 18 .hdf5. So that has been done. So the next thing to do now, we want to train. Since we have our model, we have our data set, we want to train now. So before we train, like I explained earlier on, that you need to configure your configuration, that is specification file. And this is the path to the configuration file, the specification file, this file here. So we want to see the one for training is the one we call the classification underscore spec.cfg. So we can open that and see what is inside. So if you look at it, this is what I showed you before. The architecture is what ResNet, the layer is 18, our input is 3 by 224 by 224, the path to our training, the path to our validation set, the path to our model to be trained, all of that you can see here. And then the number of epoch, now this is 80, we cannot use 80 now because this is for demo. So otherwise we want to sleep here. So we need to change this for this demo. Yeah, so for this demo, so we can come here, I can come here. So if you are training on your workstation, you don't need to change because that is your own time. But now we just have limited time. So what I will do is what I open this. This is the one for training. Then I will look for where we have the 80 just to show you, it's just to show. So we are less concerned about accuracy now because we'll just use 4 epoch so that it can train faster. And when you say 4, we have to consider the evaluation also because this is for 80. So you have to change, I have to change this also. But you don't need to bother about this. This is just tuning for me. Ideally, you should train with 80 epoch or more. Because for training, because for demo, that's why I reduced this to just 4 epoch. So I've saved that, then I close that, I get back here. So let me relaunch this one again and see, okay, it has been infected. So we can go now, we know we'll train for just 4 epoch. The result might not be good, but we are not bothered about that one for now because we just want to show you demo. So here you can train. If you want to train, you have classification, then this keyword train. So this flag here, E here, what is specified is that it's referring to the specification file, which is we've just configured now. And then, so when it finished training, where does it need to save it? This one refer to that. It will save it in a folder called output. And then it needs an access. So this is the key access. So these are the flags to use to do that. So this is meant for just single GPU. So because I have 2 GPUs, let me use 2 GPUs. This is meant for 2 GPUs here. So I can just specify this as, so if you want to specify number of GPU, this is how you do that. iPhone GPU s then 2. If you have 4 GPUs on your workstation, it will be what? 4. If you have 8, it will be 8. So I have just 2. So I can use this now and run this. So it's running now. It's running. See, it's running. So it's running. So okay, can see. So this are the is loading the layers of the model here. It loads them, and then it will continue to the epoch. So you can see here to start running the initial epoch. So it's run them epoch by epoch. So we are on the second epoch now. So it wouldn't take us more than 2 minutes to do to complete everything. Then, so the next, what you can see here, why that one is training. The next phase here is I've commented this one out. This one is meant for maybe you train and you are unable to complete your training, you just halt it somewhere. So by the time you want to start your training again, instead of you starting from the beginning, you can continue from where it stops. So you can continue from where it stops by what specifying the word initial epoch. So let's say we stop at 4 epoch now. If I decide to continue this training tomorrow, I don't need to start from 1 epoch again. I will just continue from the word where it stopped, 4 epoch. But we will not be needing that for now for this demo. So it's almost done here. It is almost done. So you see, it's how do you know it's almost done when this is still there star? So now when it gives it a number, everything is done. That cell has completed. So it has finished successfully. We can see this is the loss and this is the accuracy 0.4. But because we trained for 4 epoch, so we're not expecting the accuracy to be that good. So, but that is just for a demo. It's just for a demo. If you train with your 80 epoch, the accuracy will be fantastic. Then we need to evaluate what we have trained. So how do you evaluate? You have what this to evaluate. Evaluate, then classification, then evaluate. You have you specify the configuration file, which is the specification file, and the key also. This is what we specify. Then let me run that. It's going to do the evaluation. So during the evaluation, it will plot the confusion matrix and also give us the precision and also the recall and all that. Everything will be given. So it is almost done. So it's trying to calculate the precision, and we'll see all that. And once it's done, you will see it will give it a number here. So yeah, this is the confusion matrix. Then it will then go to classification reports. You will see the classification report here, precision, recall, F1 score, support, and all that. So I think it's done now. Yeah, so we can proceed further. And then so we can now prune. Yeah, this is where you prune. So for you to prune, we need to create a folder where we will store our pruning. We create a directory where we store our pruning. This is the epoch. The default epoch is 80. So because I'm using 4 epoch, I'm going to swap this to 4. And then so how do you prune? You have your classification and the keyword prune. Yeah. So you supply where is the model that was trained. This is where the directory it is. So where do you want to store when you prune? The prune, you will store it here in this directory output. Then what percentage do you want to use to prune? Well, we just want to prune 60%. This means 60%. If you specify 0.2, that means 20% of the model will be pruned. So we can run this now and it's going to do the pruning. So while that is going on, so after the pruning is completed, then we can view the file here. We'll be able to view, okay, that is done. It has given it number 11. Then we can now see the pruning. Yes, okay, this is what it saves. This is the name of what it has saved. Then, so because we have pruned, there is need for us to retrain again. So when we want to retrain, we have to use the specification file, which is for what? For retrain. And then, so let's cut this and see what is inside. This is what is inside. It's the same thing as for the train, but the parts that are different is the retrain part and the evaluation part. Also here, we cannot use AT because we cannot wait for long. So I will come here again and look for, okay, this is the retrain, and change the number of epochs to change the number of epochs to 4 so that we can just train with that. And then the evaluation here, I will change that one, okay, as well. So I can say save, come to save, then close that, come back to here. Then what I need to do is to let me check here whether it has been affected. I think so. Yes, it has been affected here. You can see here. Then we can proceed further here to retrain. So to retrain here, I would like to retrain using 2 GPU as well. GPUs 2, so that it can be faster. Then do that. We're almost done with this. So you can see this is making things effortless, I must say, because we are using multi GPU here. If you are to write it from the scratch, it's going to be a lot of effort. Now we are not writing any special code here, and we are training our model. We're not writing any special code. What we only did was to just bring our raw data and do some configuration with the specification file. So it's loading the model already there. So then it will commence the training. So you can see how it is being trained. Yeah, so once this is done, the next thing to do is to proceed to testing. So to test is also evaluation. So you have just, the keyword is just classification, then evaluate. So with what specification file? So with this specification file, but retrain specification file, then you supply the key as well. Well, second epoch, so in less than 2 minutes, we should be done with that. So if we once it finishes, then we test, then we can now do our visualize inference. Yeah, we can can do our inferencing, and once we are done with the inferencing, then we'll be able to export our model, and that is done for done. So successfully retrain. That has been retrained successfully. You can see it has given that. Then what do we need to do? We need to test that. So what we do is what we test that. So that we also go into testing. It's just the what we do even when we write it manually ourselves. You know, when you train a model, you have to test it with some data sets. Since we have a test data set, so it's good to test with that. So it's going to test, and then once it for the testing is just evaluation. It will plot the confusion matrix, and then give us the classification report there. So after that is done, the next thing to do is what? Okay, well, let's start to inference. So what we're trying to do here, you can write this on your own. It's just that we want to select a particular image at random from the test folder. So from the test folder here, let me come here. This is data. From the test folder here, we just want to select a random. Want to select a random data from there. So if I run this, that is what is doing here. So it's just pick a class, the class is train, and it has picked a particular image from there. So I'm not expecting it to be able to identify this very well because we train with 4 epoch, mind you, but this is just a demo. It's just for you to know the flow. So I do that, then here to run the inference here. So even if the inference is not, the result is not correct, with I'm not bothered with that. Is say because we are just using it for demo here. Then we'll be able to see the report it gets. It loads the model. Oh, luckily it's able to get it as train. I think it has. So what did we select? Is it train? Okay, the class is train. This is the image. It was able to identify it also as train. The label. Well, okay, we are lucky there. So we are lucky there with 4 epoch. It's able to recognize that. Then also we can train. We can also evaluate it inference on set of images. So on set of images to inference that you can do. You have classification, then the keyword inference, then which specification file to use retrain, where is the weight of the retrain model, the parts, the key here, the batch size 32, or then data, where do you load the class, the name, the no, which folder do you want to use to evaluate to inference. So the folder, the folder we want to use the test one, and we want to get a person from the test one. So from the test one here, you see if you come to data test, if we look for person, this is person, so it we want to use it to test all these persons here. That is what we want to use it to. We want to test with that. So come back to data. So that is what we are doing here. Then it's this one we CM we indicate the class name. So it will display graphics face, and we can be able to see whether it's classifying well or not. So and that we go, and then okay, it is done. So what we need to do is to visualize the results. So we can visualize the result with this. Running this cell to visualize the result. You can write yours. Okay, let's see, it's able to classify that very well. Okay, get this is boss, this is person, this is not airplane, this is person, and this is person, because we train with 4 epoch. By the time if we train with maybe 60, 80 epoch, everything will be the answer will be perfect there. So so the next thing need to do is to export our model. So how do you export your model? You have the flag here, which is classification, then the keyword export. So export which model, where's the part of the model? This is where the model is saved, the part. And where do you want to export it? Which folder? This is the part of the folder here. There's a folder that we call export here. Then you need the key also to do that. So we just run this, and then we will have almost using an hour. So this will run. Then after this run, we just validate that whether it's actually saved in the path we specify. We shall do that. Okay, I think that is done. Then let's check here. We check that it is okay. So that is that about NVIDIA Tau Toolkit to use. It has saved it here. So you'll be able to check your folder. You see classification. You'll be able to see export. That this is the model there. Has been exported. This is the pre-trained model. You can also see that here. So all of that is done. So what I will do now is just to clear this. Then shut down this kernel because we need to move further. So after shutting down this kernel, I can just close this. Okay. All right. Yes. And then come here I'm stopping this. Okay, let me have clear. Okay, and I can close this. So we will proceed. So we've run that demo. Then let's look at the little time we have if we can move to YOLO 5. So YOLO 5 for computer vision. YOLO is a family of object detection. So we use YOLO for object detection, specifically based for computer vision. So, and where do you get that? You can get that by visiting this website here. This is the original website. And then this is the GitHub, rather. So you go to GitHub, we clone, you can clone this repo. So then how do you do that? You need to clone following these steps. After you clone, then you have you CD into the file, the folder, the directory, then you install some requirements. So after you've done that, then you can now run your YOLO. You can run it because it can detect up to 80 objects. So you just run Python detects .py, and then source. Source means the input. Where do you want to get your input from? If you want to supply input from a webcam, a single webcam, you put it 0 here, so it shows input will be coming, and you'll be seeing the computer vision. The data will be what? Object detection running live. If it is images, you supply image here, the part of the image. Rather than putting 0 here, you put the part of the image. You put the part of the image there. If it is video, you can also do detection on video. So you put the part of the video there. Then if you want to do object detection on set of images, you also put the part there. And you can do as well for YouTube and also for RTSP also. You can also run that there. So having done that, so where does the transfer learning comes in? It comes in when you want to use that particular model for your custom data. So they call it custom data training with YOLO 5. So you bring your own data, not the data in the YOLO. So YOLO 5 was trained using COCO dataset. Now you have your own data. So how do you prepare your data set? You have your data in this format here. So test, train, and validation in this set here. So in each of them, you will have folder in each of them, which is called images. This is where your image will be, and you will have another one, label, although this label will be empty at first. So the next thing to do is to what? Is to label these images. So how do you label or you annotate these images? So you go to what we call the RoboFlow. This is the website here. So in that website, you upload your data there, and you do labeling, and after then it will generate this label file for you. Or you can also use what we call the YOLO mark, although you may need to fine tune some other things using YOLO mark, because YOLO mark is specifically dedicated for YOLO V4. But however, the only thing you need to do is just the way it arranged the classes. So it will generate the label. So what is inside the label? This is what is inside the label. Yeah, it has 5 features. Now the first one, it will give it the object class. So if you are classifying 5 objects, so it will be, you will give them value of 0, 1, 2, 3, 4. So this is an object class. The second one is the X center of that object in the image, and this is the Y center of that object. And the third one is the Y center. The fourth one is the width of the image, and the last one is the height of the image. So if you see, the second one here is 0. This is another class. Then the next thing to do is to prepare your data.yaml file. So the data.yaml file is what you have here. So you have to add these parts. So based on your folder, the YOLO folder you clone, YOLO V5, then you include dataset part. This part is to this data. Then your train, you will have your train and validation. So it will be train/images, train/validation. Once you use Robo will help you to generate these. So the NC here means what? The number of classes. Let's say we're considering 2 classes, And the name of the classes is just this. So you have two classes, dog and person, which is what, two classes. So after you have done that, so your data set will look this way. You have test, you have train, you have validation, and you have your data.yaml there. So the next thing to do is to select the weight you want for YOLO 5, because YOLO 5 has set of weights, different set of weight based on the model. So you can have, this is for YOLO, if you want to consider nano YOLO, if you want to consider small YOLO, you want to consider medium size, large size, or extra large size are there. And these are the data set, these are the weights that you can download. This is how they look like. So after you've done that, then you can train your custom model. So how do you train your custom model? You can train them using this Python 3, because I'm running on Ubuntu. That's why we have Python 3, train.py. Then this IMG is talking about the dimension of your image. Then data, that is where is the path to this data YAML. You specify that. And then there's the configuration file for YOLO 5. This is the part, you specify it. Then the weight you want to use based on any of these. So if we select large, so the weight will be YOLO v5l.pt, that is the weight. And then the batch size, and then the number of epoch you want to. So after you've done that, then you can also run, if after you've trained successfully, you can run your inference using this Python 3, the text.py. Then your source, if this is an example for using camera, webcam camera. So when I say source, it's 0, so that is webcam camera. Then the weight, so the weight will not be the weight that is here again, because this one is YOLO v5 weight. Now you have trained your model, the weight will be saved in this part. And so it will save it as .best. So you specify that weight and the image size, and then you are good to go. So all of that you can see, you can be for custom image, you will be able to access them in this with this link. So I will give a demo, but unfortunately we might not be able to use webcam because I'm doing SSH. I've been trying it, but it's not working with SSH. So what we need to do now is to come here. Okay. So first thing to do is to download. So let's go here. Okay, so this is the site for the GitHub for YOLO v5. So you can see it for the YOLO v5. There are requirements there, the steps to follow. So we can come here and say, okay, let's copy this git clone. You just copy git clone, and you are here. So I can put that here. So it will clone. I hope there's no, because I've run this before. So let's see then. CD v5 then. So the next thing to do is to what? Pip install the requirements. I hope there will be no conflict because I've done this before. So because I'm on Ubuntu, my pip will be pip3. So it will do that. Oh, okay, since it has been installed before, it will be there. So now YOLO v5 is ready, not the custom one, but YOLO v5 is ready now. So how do we run YOLO v5 now? So if I want to use, what we call the webcam, there will be an issue, but I will show you. So if I say Python detect source with this, there will be it will complain of something. So it will be Python 3 rather. Okay, so Python 3 detect. I hope you can see my screen. So this is Python 3 detect. So okay, so it's running now. So it's downloading the weights. So it aborted because ideally there is we cannot use webcam. So what we need to do is, let me just show you. Let me go to my folder here. So once you download your YOLO, this is YOLO. So once you download it, this is how the folder looks like. So the folder looks like this. Then what we need to do in order to run that is, if you go to, you need to include a new a folder for your data set. So the one I've done before is that I included the new folder. This is the one I've done before. So I included this. This is the data set. So what happened here? This is the test. Okay, let me show you. This is the test. So you have its image and what? A label here. So this is the image. I'm just using this. This image is for Tama image for dog and person. So then the label is in this format. So if you look at the label here, this is the format here. It's in this class, which I've shown you before. But how do you get this format? So for you to get this format, what you need to do is to go to please. I want to waste the time. What you need to do is to go to Robo. Yeah, there's a Robo here. So this is custom data training. If you want to do custom data training, so when you get to custom data training, you go to Robo. This is Robo. Then you need to sign in. I don't know if it allows me to sign in because I've been signing in before. Yeah, so if you are not signed up before, you can sign up. So once you sign up, what happens is you create a new project and upload the data. So when you upload the data, for example, the one I have here, then you go to annotation to annotate the data. So this is the data here. So I can click on them. You start annotating. You will have specified the number of classes because I'm dealing with 2 classes here. So how do you annotate this one? Once you are here, so you just click on you just have this. So you draw the box. It's called box. You draw it there. So once you draw it there, so the class for dog is one. You save that. Then you proceed again to the next one. So you can draw the box on that one as well. Draw it there. Then you save the class is one. By the time you get to another object which is not dog, you continue doing the same way. So let me shift forward and see if I will see the one that include another one. Now, okay, in this case, this is 2 class. So what you need to do, I will draw the box for the dog this way. The boxes can overlap. Yes, I will say enter. That is 1 for dog. Then the class for person now. This is how I will do the one for person. Yeah, yeah. So the person, which is what the class is 2, then I can save that. So that is how you do with Robo there. So let's come back here. I just show you how we came about this label. That is how we came about this label. So it's going to generate it in this way. So once you draw the box, this is the class. This is the for the X center, Y center, then the height, the width, and the height of the image. So we're about rounding up. Then before we round up, let's just look at this. So since that one is done, so what can we do? I can test with this image here. Let me test with this. Just do that to run. So before I run that, there is an image here. So in the YOLO, which we opened, where is the YOLO here? We downloaded. So if we go to data, then images, there's this image here. So we want it to identify this image. Since I can't use webcam, we can use it to identify this image, and you will see what will happen to that. So then, so if I run this from the run track, then we run and save. So save it as save it. So example of that. So it's on my, it is on my job station. Then what I did is what I've put the image here somewhere. Okay. then the image can be here, which is under SP2. Then I can see where we have bus here. Okay, yeah. So you can see how it does the classification. It's able to recognize that this is a bus, this is a person, this is a person again. This is also a person. Is able to recognize that. But if you have, if I'm not using SSH, you can use you can use this direct, and even with that, if you have run that, I think I ran one before now, which is under run dot train. Is it train or detect? Well, yeah, yes. So this is the way it's supposed to run. You can see this was the live one I did not too long. It will be recognizing this is a couch, this is a chair. That's how it will be running. We'll be seeing all of that there. So now let me just show you how do you train the custom. So for the custom, what we need to do for the custom image to train is to then copy this. I will explain this to you. Since we've set everything here into our YOLO, so into the YOLO, what you need to do is this data set is there. You've put your own data. This is your test. This is your train. This is your validation is there. After you have downloaded from RoboFlow, then this is the YAML file. Let me open this YAML file for you, data.yaml file. So you add this part there. This is YOLO.dataset, YOLO5 dataset. All this will have been there from RoboFlow. Will have given you all this train part, validation part. This is the number of classes. If the tax, your data, maybe you are dealing with 10 classes, what will be here will be 10, and you will list the names of all the classes here. So I'm just dealing with 2 here. That's why I have this one here. So this is how it looks like there. So to complete that one, so what I need to do here is okay. So I will need to run that here. I will need to run that here. Then come in, please. Working on this to put it there inside my model. Almost done with that. Copy this, bring it here, then paste here. Okay, so here you have the train.py. This is the image size. This is the date. This is the path to my data, which is dataset data.yaml. This is the configuration file. This configuration file is the one for YOLO v5. The one for YOLO v5 is you can see from this part here, model. So if I come back to model here, this is the path to the file here. Let me increase the view here so that you can see the view. So this is the folder here. This is YOLO v5.yaml. That is that for this. Then the weight, I'm using this weight. It's going to download this weight by itself. It doesn't exist. 64 batch, and the number of epoch is just 100, but 100 will be too much for that. So let me just say 20, and let's see what happened there. So this is how you will train. So after you train, you can also do inferencing the same way. See, is downloading the weights itself or the large. So it's running the configuration, and this is how you train with your custom data, and you start inferencing just the way others, just the way we've done the initial one as well. So you can inference with that. So it keeps running. Well, keeps running. I know you can do the inference yourself as well by following the presentation that we. Thank you for listening.